Hi there and welcome to today's class. Let's proceed in the study of applied mechanics, which include resolution of vector in 2D. So I've done several videos, so like 1, 2, 3 videos, right? That explains the idea behind vector in 2D, how to resolve vector in 2D. This is fourth example we'll be trying to evaluate. Let's see how we can possibly solve this particular question using the idea we have learned so far in our previous classes. First things first, this one says, the question attached diagram says, the three forces F1, F2, F3, of course, I have F1, F2, F3 act at a point of course here at a point here at a point A. So it means that there should be A. Yeah. So it means F1, 2, 3 act at a point A. Said on the hanger below, perhaps mine is above, right? You can do yours below, right? Along a specified direction, determine the X and Y component of each of the force and the resultant force are in vector form. So in this case, what do you do? Basically, from initial knowledge, when we are asked to find resultant force, right? What do we know? Recall that I gave you the formula. Recall that we said to get resultant force R, that gives you, perhaps it says resultant force in vector form. So I'll not use R. In that case, I can say FR, resultant force in vector form. So I should put an arrow here that indicates the vector form. That gives you summation f of x I plus summation f of y j. This is the formula we have to use to calculate for resultant force in vector form. I have given you this in our previous classes. So let's see how we can possibly find for f of x and f of y, as we are told that determine the x and y components. So it's that the idea is that you can't look for resultant force without looking for x and y components. So let's see how we can possibly find the x and y components. Before then, this man here, this is a F2 and an angle. I can resolve this man, is resolvable. But observe F1. F1 is 500 Newton, but an angle is not given. I'm given perhaps a rectangle triangle where I have 3 and 4 as the adjacent and hypotenuse. Opposite and adjacent is given by 3 and 4. I'm not given angle here. So what will be the tax? So here's the idea. What we have been doing so far is force and angle. So F2 has a force and angle, no problem. I can resolve it. But this one here, it has just a force, no angle. Let's get the angle. Also, F3. This F3 here, F3 to the horizontal, to this horizontal, there is no angle here. So I'm going to look for F3 angle. F3, right? That's the tax. So let's analyze before we start solving. Let's try to get, okay, let me call here theta 1, theta 1. Let me call the angle here, let me call it theta 2. So let's try to get theta 1 for F1, theta 2, okay, theta 2 for F3. Or in better form, theta 1 follows the idea of F1. So theta 3 should follow the idea of what? F3. So let's use theta 3. So theta 3 to follow the idea of the F3 there. So let's start with analyzing F1. So analyzing F1. Sorry. So analyzing F1. So observe please, for F1, listen please. I want to look for the theta here. I know F1 as 500 Newton. I want to find a way to look for theta 1 so I can be safe. So theta 1 now, here's the idea. I'm given a rectangle triangle. I'm given this. This is given as 4. Here is 3, right? So let me call here theta. So theta to this. So it's like saying this arrow here is this one here. This one here is the 4 we are seeing here, right? So let's get to theta 1. Let me call here theta 1. Now, here's the concept. Go back to what we know. Go back to SOHCAHTOA. For SOHCAHTOA there, listen, I want to get theta 1. What do? What do I know here? I know opposite and what? Adjacent. Check. Opposite hypotenuse, no. Opposite adjacent hypotenuse, no. Opposite adjacent. So I have these two. So I'm using what? Tan. So in that case there, I'll have that tan theta equal to what? Opposite adjacent. So that's opposite over adjacent. So theta here is theta 1. So put theta 1 here. This one gives you tan theta equal to opposite of cos 3 all over 4. Take theta 1. Take tan there. That gives you theta 1 will be equal to what? Tan inverse of 3 over 4. From here, theta 1 will be equal to tan inverse of 3 over 4 should give about 0. Let me just try to punch it out. From here, divide 3 by 4. 3 divided by 4, that gives 0.75. 0.75. All right. Let's get theta 1, please. From here, theta 1 will be equal to, if I take tan inverse of this value, let's see what we'll get. Tan inverse of this value. Okay, tan inverse of that value, 0.75. This one gives about 0.64 degrees. So I'm saying that theta 1 here gives 0.64 degrees, right? So I've gotten theta 1 here. So it means that I know F2, theta 2. Welcome, guys. I just launched a course. The course will teach you how to start your own YouTube channel. If you're a teacher also trying to do what I'm doing, you can get this course. The course costs about just 10,000 naira. You can get a course and you start uploading your videos on YouTube. Or if you're a beginner trying to explore YouTube and you're having interest in learning how this YouTube thing works, you can do well to get this course. As you can see the banner of this course in the video, in the screen of the video, right? So do well to go and get the YouTube course so you can earn, learn, and also grow your platform. See you guys. If this interests you, do well to message me up or click on the link you see in the video description that says YouTube course. See you guys in next page. All right, so let's get theta 3. So I've got theta 1 as this value. Let's get theta 3. Now here is the idea. To get theta 1, I use the idea of a right angle this way. Of course, if you observe the theta 2, so theta 3, this one here, observe this shape. This man here is giving you a right angle triangle, right? So I'm having something of this nature. Observe. Analyzing F3. So let's get an angle of theta 3. Now observe that I'm having something of this nature. If you observe very well, something of this nature. All right, this one here, such that observe that from year to year gives about 0.1 plus 0.3. That gives you 0.4 meters. We said from year to year is 0.2. Year to year should be what? We just said year to year is 0.4. So 0.2 plus another 0.2 gives you total of what? 0.4. It means that year to year is 0.2, which means year to year is 0.2. So I mean 0.2 this place here in meters. So let's try to, so the angle here, the angle theta 3 is at this point here. So let's apply SOHCAHTOA concept to get the theta 3. Now, what am I given? I'm given opposite and then adjacent. I'll still use tan, right? So I'm saying that tan theta 3 is equal to opposite of adjacent. opposite over adjacent. That gives you opposite is of course 0.4 over adjacent is of course 0.2. Divide these two, what do you get? Theta 3 tan theta 3 will be equal to, divide these two values, what do you get? That gives 0.4 divided by 0.2. That gives about 2. So that this one gives 2. Take tan inverse here. Tan, theta 3 will be equal to tan inverse of 2. So theta 3 will be equal in value to tan inverse of 2. That's 1.10. That's 1.10 or 1.12 degrees if I want to. So I've gotten theta 3 and of course I've gotten theta 1. So let's go back and put in the values there. So I'm saying this and saying this again. Look up please. I will erase this question. I will erase this question and put in what I have now. So look up please. From here, we said F1 is of course 500 Newton. Theta 1 is of course, theta 1 now said is 0.64. That's 0.64 degrees. Let's do F2. F2 is 600 Newton. Theta 2 is all about 35 degrees. All right. What's F3? So F3, this one here, F3 is all about 800 Newton. Theta 3 gives about theta 3 1.12. So that gives about 1.12 degrees. So let's get the x and y component of this concept. All right, and get resultant force in vector form.
Guys, I just launched some courses on my website. These courses include physics tutorial for year 1 student, YX/JAM student, YX/JAM classes for JAM student, and also I have the organic chemistry for beginners. So these courses, you can get these courses on my website, as you can see displayed at the right hand side of the screen.
All right, so let's look for summation. So let's do summation of horizontal component. That's summation f of x. That's summation f of x, which is equal to, now look up please. Let's get started please. Let's start with F1 please. For F1 is inclined an angle to the horizontal. If I resolve F1 to the horizontal, that gives cos. Why? Because angle is lying on horizontal. That gives me F1 cos theta 1. I'm not F1. Resolve F2 to the horizontal. The angle is lying on the horizontal. So if I resolve F2 to the horizontal, it means I'm having cos. That gives me, and observe, please, observe. We said go back to your quadrant, please. For your first quadrant, take x as positive, y as positive. Second quadrant, take x as negative, y as what? Positive. I have fourth quadrant here. Take x as positive, y as negative. Of course, when I resolve x for my x axis here, for horizontal component for x should be negative. Now I resolve this one to horizontal. I think that I'm having what? A negative value. So negative f1 cos theta. All right, I have this one here. Next up, if I resolve this one to the horizontal, it means that x there is positive. So it's not about positive. Resolve f to the horizontal gives cos. That gives you f2 cos theta. Cos theta what? Theta 2. Yeah, theta 2. So I'm calling this theta 2. Next up, if I resolve f3 to the horizontal, so this x, if I resolve f3 to the horizontal, the x part there become positive for first quadrant, right? So I'm seeing I'll be having positive f3 to the horizontal. That gives you f3 cos theta 3. Why f3 cos theta 3? Because the angle is on the what? Horizontal. So that gives you cos theta 3. I have this one here. Let's put in value, so we'll get the summation of f of x will be equal to negative, what's f1? 500 cos theta 1 is of course 0.64 plus f2, which is positive, f2 600 cos theta 2 is 35. Next up, plus f3, f3 is this 800, then cos theta 3, it says what? 1.12. This one gives you summation of f of x will be equal to, if I punch this value, what do I get? Punching this value, 500 cos 0.64. This one gives about 401.04 plus, if I punch 600 cos 35, 600 cos 35, this man gives about, in brackets, negative 542.21. Next up, plus, if I punch 800 cos 1.1, 800 cos 1.12, that gives about 348.54. Work on this here. Of course, don't forget there should be negative here. Negative. This one here gives you this value. So summation f of x will be equal to negative 401.04 plus minus gives you minus 542.21, then plus this plus sign here, plus 348.54. All right. Summation of f of x component will be equal to, if I punch these values, what do I get? Negative 401.04 minus 542.21, then plus 348.54. This man gives about negative 594.71, of course in Newton I. So my summation of f of x, let me just put the value somewhere. Summation of f of x is equal to minus 594.71. Now let's get summation of what? F of y. So this is how we get summation of what? F of x. So I've gotten the s component. Let's get the y component. All right, for the y component there, automatically for the y component, it will be sine. Sorry, it will be sine all through. Yes. I've resolved everything here to the horizontal. Right? If I'm to resolve vertical component now, everything gives me sine. Right? So
I just launched my website www.ghanabukari.com, as you can see in the screen. In this website you can get close to 4 to 5 tutorial courses that are there. So we have different courses there. Also, the book I just launched also is in the website. You can visit our website and get the courses you want to watch. And also, the video you're watching recently, you can get more of these interesting videos in the website. So do well to visit the website and also register an account with my website. See you guys in the website, and make sure you buy a course from the website to support our journey of this academic platform. Thank you guys and welcome to my channel.
Vertical components, that's summation f of y. So let's see what we get here. This is now equal to, if I resolve this man, f1 to the vertical component, that gives sine. That gives you f1 sine theta 1. Now, in this case here, in this second quadrant, just take y as positive, x as what? Negative. So it means I have a positive value here. So next up, if I resolve f2 to the vertical, that gives me plus, because our second quadrant, both at first quadrant, both x and y are positive. So I'm on y-axis now. That gives you plus. Resolve f2 to vertical, that gives you f2 sine theta 2. Finally, resolve f3 to the vertical. That gives you, for f3 there, for third quadrant, for the fourth quadrant, we said take x as positive, y as negative for third quadrant. So I'll be having negative f3. f3, resolve it to the vertical, that gives you sine theta 3. Let's plug in values and let's see what we get from here. This one gives you summation of f of y equal to f1 is 500, 500 sine theta 1 is of course 0.64, 0.64 plus f2, that's 600. I have 600 sine theta 2 is 35, 35 degrees. Negative f3, what's f3? That's 800, 800 sine theta 3 is of course 1.12, 1.12. Let me punch this and so we'll get summation of f of y will be equal to 500 sine 0.64. So if I punch a calculator, 500 sine 0.64, yeah, that gives 298.59 plus 600 sine 35, 600 sine 35. This one gives about negative 5, negative 256.90 minus 800 sine 1.12. 800 sine 1.12, 800 sine 1.12. This one gives about 720.08. So work on this one here. I'll have that summation of f of y will be equal to 298.59 plus 1 gives you minus 256.90 minus 720.08. Work this one out. What do I get? This one gives about 298.59 minus 256.90, then minus 720.08. So it means that my summation of f of y will be equal to negative 678.39 Newton J. So I've gotten the s component and the y component. So let's get the resultant vector. Let's get the resultant vector. The resultant force in vector form. And we said the formula is given by f r equal to summation of what? F of y I plus summation of what? F of f, f of x plus f of x I, this one j. So this one gives about negative, so I have negative 594.71 I, perhaps Newton I, if I want to, Newton I plus, this one there is negative, into negative 678.39, of course, Newton J. All right, I have this. Work on this. I'll have, this gives you negative 594.7171 Newton I, plus minus gives you minus 67839 Newton J. All right, if I want to, I can factorize out the Newton, right? So what do I get in this case? Perhaps I can leave this way, but I can still proceed to solve it. So it means that my final answer, so it means that my resultant force in vector form will be equal to, in brackets, negative 594.71 I, then minus 67839 J. Of course, Newton should be outside this way. So this becomes my resultant force in vector form for this particular question. You go further by getting me the magnitude of this resultant force in vector form, also get me the direction for this question. So leave the answer to the two questions I give you in the comment section below. I'll reply you if you are wrong or correct. So if you found this class helpful, go to like this video. So if this is your first time in my channel, do subscribe to this channel and also leave a comment. The comment you are leaving is of course question 2 and 3. I said get me the magnitude of this vector form resultant, also get me the direction. See you guys in our next class. Oh, we're looking at equilibrium of forces.
I just launched a book called The Shortcut to Academic Success. In this book, I share a lot of experience on how I evaluated during my time in school. This method really helped me a lot. If you're interested in getting this book, simply chat me up through my WhatsApp number that is shown in the screen,